Welcome to ARP Spoofing. This is gonna be great. To get started, I've got PC1 here that wants to communicate to the web server. PC1 is on the 192.168.1.0 network. The web server is on the 2.0 network. For PC1 to get there, we've got to make our way through this router, which is R1. R1 is acting as the default gateway of our network with IP address 192.168.1.254. R1 has the MAC address ending in 9902. So PC1 is going to have to communicate with this router in order to make its way to the web server and get a response back. Now, quick recap of how ARP works. In order for PC1 to get to the web server, it needs to know the MAC address of its default gateway. So let me open up PC1, go into my command prompt, and we're going to do an ipconfig /all. And with our ipconfig /all, we'll see that PC1 has its MAC address of B0EE. It's got an IP address of 1.10, and it knows the default gateway IP address. It knows the router is 192.168.1.254. However, if I take a look at my ARP cache with an ARP -A, there's nothing in there. It doesn't know the MAC address yet for router R1. So if I were to send out a message, like maybe I want to ping 192.168.2.100, that remote web server, the first ping is going to fail. And that's because my PC1 is resolving with the who is 1.254. And by the time that ARP resolution happens, the first ICMP ping message timed out, but that's okay. The other three were successful. And now when I check out my ARP cache for an ARP -A, we can see that my default gateway 1.254 is known as MAC address 9902. Now this is awesome. Lab is complete. But what if it's not complete? Well, just to kick it off, one last thing to try out here. I'm going to open a web browser on PC1. And now that we have layer 3 reachability to that server, I'm going to go and use port 80 of TCP and hit that server at its IP address. And we have connectivity on port 80 using TCP. So this is great. But when does that threat actor come into play? Well, how about now? My threat actor, I'll open it up and go to my command prompt, has an IP address and MAC address already. And this is just a normal user on the network that has too much time on their hands, maybe. This user has a MAC address of 20A8. It has an IP address of 1.20. And it also understands that the default gateway is 1.254. But what if this threat actor wanted to be a man in the middle? Well, we can make it happen. I'm going to go ahead and go over to my router R1. And I'm going to go into my interface that's connected to this 1.0 network. I'm going to grab that MAC address. And then we're going to go back to that threat actor machine. And don't worry, threat actor, we're going to give you a gift. On the threat actor's interface, we're going to change its MAC address to spoof the MAC address of the default gateway. Now that it has the MAC address of the default gateway, let's have some fun. I would send a gratuitous ARP over to PC1. Because I don't have the ability to do that here in Packet Tracer, how about we send a constant ping? And this constant ping is going to be talking with the IP address of PC1. And you know what? Who's the source? Us. Us, threat actor machine, now with this spoofed MAC address, which would be the default gateway. And I want to show you something. On PC1, let's take a look at our ARP cache now. ARP -A. We see that 192.168.1.20, hey, check it out, has that MAC address of the default gateway. And also, let's go over to the switch. Our Cisco networking switch. Let's verify our MAC address table. Show MAC address table, dynamic. And let's take a look at the MAC address learned off of port 2. And check it out. Off of port 2 is the MAC address now of the default gateway. So now what happens when PC1, which we're going back to right now, tries to browse the web? Open our web server up. Let's go back to 192.168.2.100. Enter. And it's just timing out. And you see there's no activity lights moving here at the top regarding this traffic. It's a timeout. But now comes the fun part. If our threat actor is running a type of analyzer for traffic, such as this network sniffer sitting here right outside, I can go into and click on one of those messages, and I can actually scroll through and read through the headers, as well as even be able to read through the data fields of the traffic. And what we can see here is the source IP was 1.10. That was PC1. The destination IP was meant to go to 2.100. Well, then how was it switched over to the threat actor? Because the switch thinks that off of port 02 is MAC address 9902. The spoof was successful. If I scroll down, you can see here in layer 4 info that this thing was targeting port 80. destination port 80, source port 1026. Man-in-the-middle attack, successful. And if we had better threat actor software, we could literally capture this data and at the same time be sending it onwards to the default gateway ourselves, acting like everything is just fine, using a beautiful